So if you look closely, or if you kind of scope in and out and you let your eyes blur it, you can kind of make out features. And it might seem silly to you if this is your first time that there's layers here. But if you stare long enough, and that's what grad school is for soil science, you stare at enough pits, you kind of begin to pick out layers. So in that app, you've got these idealized layers. Let me pull it up. Right here. You can kind of see how they've got the AP, the A, the B. So these are layers that are shown clean cut, and this is the reality versus the expectation, so to speak. And there's information in these layers. Basically, it means that each layer is significant in how it formed. It tells you something about this individual soil. It's almost like, do you have brown eyes? Do you have long hair, facial hair? These are these different features. The big letter means something important, and there's basically three kinds of layers that are shown by the big letter. So A, B, and C. Pretty simple, right? So the A is the surface, and that is in general characterized by organic matter accumulation. That's the A horizon. Then you've got that B horizon, and that would be about here. So B is where you get buildup of anything. So that could be buildup of clay, buildup of iron oxides. And typically what this means is that you've got the roots growing up here, which you can see, hence the A horizon. And then you tend to get what's called a clay pickup. So the clay tends to increase, and there's a clay bulge, so to speak, in this B horizon. And that's because over time soils tend to generate clay. And by time, I'm talking about geological time. So over 10,000 years, this clay might increase from 25 to 28%. And then the final layer would be the C horizon, and that's the parent material. So that's the stuff from which the soil was born. So this was all once glaciated, right? Glaciers a couple miles up. Sure. Then they melted, and then winds came in and they put on this nice soft bed of silt. And that stuff is called loess, glacial loess. That's all this stuff down here. And so from this, if you feel it, you can kind of make out the texture and work it with your hand. It's almost like silly putty. Mm-hmm. So that's the stuff, that's the loess that was put down. And then as plants begin to colonize, they begin to build up this organic matter from their roots. And then as weathering happens, you begin to build up that clay horizon. So now if you feel this, compare this with what you just touched. Crumbly, but also a lot harder. If you try to break this with your fingers and to mold it, it's a different beast altogether. So now there's a couple observations that we can make, right? We've got a color difference, and that's a good place to start always, is use your eyes. You've got dark A, and then as it decolorates, you got a B or a C. The other would be what you just did, the feel. So there's two ways of thinking about how it feels. One is the texture, and that's the amount of clay, silt, and sand. You get that by working that silly putty. The other is soil structure, and that can be seen and felt. So the structure would be, are there blocks that you can chunk off? And if you look at this, there are these almost like columns that are stratified. So that would be columnar structure. If you get down here, there's no real structure now, right? It's all kind of cohesive, and that's from all the clay content. A good way to check out structure is to try to break it along its natural fault lines. You just kind of apply pressure and you see how it breaks. So this would be called blocky angular. Blocky because it's a block, and angular because there's kind of sharp edges here. If they were rounded like that, then it would just be blocky, non-angular. And this is an expression of things like the mineralogy, the clay content. Sure. So anyway, there's an entire book called Keys to Soil Taxonomy.